Alright, so it's a new day. We've got some good lighting now, and I'm not sure where I left off. That's the bad part about this. But I brought this thing to work with me because what we were going to do for the batteries is we were going to fabricate this, and the one guy that I work with has a pretty good extensive welding background, and what we had planned on doing is cutting this bracket here, mounting the controller up in this location, and then extending this, which is really all I would need to get these batteries in here. So I was having some issues with that. But I have an alternative, and I think this one's better for most of you guys that would maybe be interested in doing this. Is we want to have something that's not so extensive and something that, you know, pretty much the everyday person can do. And so what I found is if I bent this bracket that was holding the one single battery, so the factory setup would be like this. You have one battery sitting this way. I found that if I bend this bracket down, what this allows me to do is take this battery, I can turn this one sideways, and then put the fourth battery sideways next to it. And there's about a 1/2 inch air gap underneath here that I'm going to use some type of foam or some type of rubber. And what I found with it set up like this is the covers go back on perfectly with no modifications at all. So really just some slight mods on the base plate, bending that down was really all that was needed. My terminals for the battery the front one will be up here, and the terminals for the back will be here. It's no problem. I have to rewire all of this anyway. And these batteries can be mounted really in any angle. So these absorb glass mat type batteries, which is what these are. What else can I share with you before I start wiring this? I don't think I'll have the camera on the whole time for wiring. There's a few important notes, and that would be the final wiring into my controller, which is here. We want to have the inline fuse in that leg of the circuit in series to this one. So when I wire the batteries, I'll have the last leg of the circuit on the positive wire going to the controller, and I'll show you that. From there, it's pretty straightforward. I broke a wire here for my brake switch. I'm gonna have to fix that. Well, I just got done saying I wasn't going to film the whole thing. There's certain parts I have to do with you guys, and I have these kind of cheap connectors. I'm not really a huge fan of these, so what I'm going to do is I'm going to actually take the insulation off, and it's pretty simple. Just, you know, two pair of pliers. I'm using a pair of dikes on the one side, and I'm pulling this off. The reason I want to do that is I want to solder these. So here's what it looks like when I put it on one of the wires, and I'm going to put solder on these. And the reason why, you guys have to think about every single connection has a potential of a voltage drop, and I don't want to have any of those to reduce power to the bike, and I also don't want to create heat. So if we have any resistance problems at all in any of our connections, we can create heat and we can create fire hazard type conditions. Something else I wanted to point out, I am using a 40 amp fuse, 40 amp inline fuse, and that is per the instructions on this sheet. It says right here that it has a under voltage protection. Nope, sorry, just above that. Recommended fuse circuit breaker size 35 to 40 amps. Now when we did our test runs on this, we were running a 30 amp fuse with no problem at all. It did not pop even a 30 amp fuse. So the one I'm putting in here is a 40 amp. And what we want to do is down here. It says fuse or circuit breaker protection is required between the speed controller and battery pack. And that's why I want to hook up the fuse on the last battery between the battery pack and my controller. So the setup for my inline fuse is going to be, I'm going to use this last battery as my final one for my total of 48 volts. And so we'll put this one here, and then we'll run a terminal end on here. I'm going to cut this wire. We'll rewire this connector here, and that'll be where my inline fuse will be. Okay, so we're going to solder this terminal, and I'm actually going to solder the terminals onto the battery. That's the way the MX500 came from the factory, is it actually had soldered terminals on the batteries. I'm going to do that too. What you have to think about, guys, is as your kid's riding this thing, all this stuff is vibrating, and you know, things can loosen up. And so I like to, in these applications, I like to solder the terminals to the batteries themselves. Okay, so again, the plan on wiring this, I'm going to have the fuse coming off of this battery right here. And so the way my battery pack is set up, kind of tough to see from this angle, but I have the positive is down here on this battery, negative's up here. So here's the plan, here's the wiring. We're gonna run a wire from here, negative to positive for this battery, a wire from negative of this battery to the positive of here, a wire from this battery, negative to positive here, and then the final one, are negative to the controller. Okay, 48 volts in series, 4 12-volt batteries in series with the fuse up here. So I've been busy between camera shots here, and you can see that I have my batteries mounted now. I'm very pleased with what I did. For those of you that want to maybe do this setup, again, the batteries are sideways, and what I did, I showed you before, I straightened the bottom plate for the top battery, and I used the existing holes, or the threaded piece that the bolt would go down on for the hold down bracket, just bent that over and used a piece of, they call this what? A metal strapping. That's what I used. It's this stuff. Look at that. Oh, it's still hanging over there. Didn't cut the other side. It's used for like holding pipe in place and stuff. And so I used that to put 2 pieces of foam underneath, and I'll show you those in a second. And then I took the bracket that was on the top and straightened out the bend on the one side, and I cut the other side over here, and I just screwed it into the frame. I drilled a small hole, screwed it into the frame. Let me show you those 2 things. Okay, so this top bracket used to be that little U clamp that went this way around the original battery. I straightened out the one side, and I didn't put this piece in yet. That was the last piece I did. I straightened out the one side, the elbow was about here, straightened that out, and then just ran it down this way, straightened out the other end, and what I found is it was too long and it was hitting the battery down here. I originally had this bolt, drilled a hole down here and had it clamped there because I wanted to have that top bracket, and it was hitting the battery. So suggestion would be to move it up here because we have distance, and that accounts for the head of the bolt. So drilled into the frame right there, screwed that in, left this off. That was my last connection. Placed the batteries in on top of some foam that I had sitting around. I have 2 pieces of foam under there, and what I did is, using this metal strap, I bolted this side down. You see on the existing bracket. Can I show you that? Yeah, it's just kind of bent down to make it easy to get my Allen key in there. I put this one on, and then I went to the other side. Let me show you the other side. This is the remainder of the strap. I just have to cut this off. And I used a longer screw, and I just pulled this down nice and tight, and I did that with this metal strap in place. And I wanted to do that because I wanted this to pull down on the batteries, which was squishing my pieces of foam in between here. So this is nice and hard mounted now. This pulled the batteries down, compressed the foam, and then from there, that's when I drilled my hole for this and then just anchored this into here. So I probably should have filmed all of that, but at least you have an idea of what I did. And of course I made sure that my batteries were centered, because when I put my covers back on, if you don't have the batteries centered left and right, then you're going to have an issue there. So the batteries are centered, and they're sturdy. That's the table squeaking that I got this bike on. I'm pleased with that. There is a little bit of flex in that battery assembly. That is not going anywhere, and primarily with batteries in particular, vibrations are bad. And really with any of the connections. So this is good. This isn't moving anywhere. It's safe. Even if he wrecks it and God forbid that happens, but if he falls over, and the batteries are going to stay where they are. They're not going to move around. I've seen some other people do them with zip ties, and that's fine, but my concern with zip ties would be in the case of an accident, or really if you're doing any off-roading, or these aren't really made for doing jumps, but in those cases I think the zip ties are really not a good answer, and I like what I have. And I did it this way because I think really anybody can do it this way. There really was no fabrication I had to do. It was only just in this top bracket and then the bottom plate that held the batteries. That was really it. So I'm going to wire this battery up now, and I think I'll just keep the camera rolling for that. When I solder the bigger connections like this, it really helps, really any soldering, it helps to put a puddle of solder in between the gun and what you're soldering, because it really helps to transfer the heat a lot better. And any extra solder, just give it a little flick. That's one. I hear my clock in the background. Sorry. It's white noise. My students hate it. This is the terminal that will be going into the connector for the main power plug. Close up of that. Any voltage drop we don't want. Any high resistance will cause voltage drops, will cause power issues. We don't want to have any of those, and more importantly, we don't want to have any heat issues. Resistance, again, I said this before, in unwanted locations creates heat, and that heat can actually catch things on fire. Can melt batteries. I've seen batteries where, like, if you take which terminal's in the screen here, you take this terminal and you have a loose connection here, you pull it apart, the whole top of the battery is melted right there. And really what caused that was your connection on the battery was loose, creating resistance. Again, resistance creates heat. As far as gauge of wire goes, it doesn't matter if you go too big. Whenever you guys pick your wiring to do this, just make sure it's not smaller than the original wiring that the bike came with. Okay? Too big is fine, too small is not. And honestly, when you go too big with the wires, it's just harder to work with. So you don't want to go too big either. I'm not really sure what gauge this is exactly. Maybe I don't want to misquote it, 14 gauge, 12 gauge, 10 gauge wire. I'm not totally sure. just go with the wiring size that comes with this thing from the factory. It doesn't have to be factory wiring, just talking wiring size. That clock is bad. Okay, so this one is my inline fuse that's going to go to my main connector. So that's going to go up here, top. You know what I should do? Should I put heat shrink on those? Nah, it's not necessary, but I could. Just make them hard to get back off. I'm not going to do it. That's what the fuse is for, if anything goes wrong. I was thinking of putting heat shrink on here and then sliding the heat shrink up and over. And if I do that, it's just going to make it really difficult to get them off. I'm okay with what I have. I don't know, it's up to you guys on what you want to do there. And I do have on this connector here, this is a heat shrink butt connector, which I didn't have before. I'll show you. This stuff's pretty cool. And this is the nice thing about a butane soldering gun with a hole at the midpoint of it. I use this to for shrink tube all the time. It works very well. This is a little bit thicker than what I'm normally using. I love that clock. I have a feeling that's going to pick up real bad in the video. You're going to use butt connectors. I'm suggesting the heat shrink style ones. They're not cheap, but better than those other style. Alright, so what we want to do is we're going to solder this first connection on the battery. And what we need to do is heat up the terminal and the male terminal on the battery and the terminal that I have plugged into it really at the same time. We need to heat both of these. And I'm just going to place that there. Get you a close-up of that. So doing our first battery, and I have to be careful with the hole of my soldering gun here. It isn't facing the battery, I'll melt it. And again, I like to put a little bit on the tip of the gun just to transfer the heat. Maybe not so good in this circumstance. Don't like to hold it there for a long period of time. That is one. It's okay that I ran some solder out of there. It comes right off. And now that is not going anywhere ever. And you can get them back off. Same way, to heat them up and get them off, you put the soldering gun in that area and wait till it gets hot and just yank it right off with a pair of pliers. So this is my other half of the connector. That's where this goes. And the top one is my positive. And what you want is the clip for this. The little locking tab would go on facing down that way. The locking tab would not be up top. Locking tab goes here. So when we push this in, it should click and hold. Okay? The ground will go on the other side. That's going to be this one. It's the other one that I made already. Again, locking tab will go down here. Okay. And there's my main power. Plug that in. I'll leave it unplugged for now. Okay. And I'll leave that connection for last. Next one is going to be this bottom piece. We're going to go from here. You know, I'm looking at how close that is to the frame for that one. I don't really like that. I think I really do want to put a piece of heat shrink on this one. I'm going to for that one. I may do it for a few of the other ones too. I'm going to do this part first though, because I have an open end on the other side. I don't need to pull that back off. Heat this. I realize I'm using a butane soldering gun too. Maybe a little safety note here. I'm okay with using a flame type soldering gun because this is a sealed battery. There's no vents in it at all. I don't have any danger of any kind of explosion. Some of our car batteries, I'm doing any soldering near a battery like that, I'll probably pick an electric one over a gas one, but just a little safety side note there. So a little piece of heat shrink I'm going to use for the end of that, because that'll act as an insulator for just in case this battery would shift at all in any way, shape, or form. That's going to make it hard to get back off, but I want my son to be safe more than I care about the difficulty of some heat shrink that I've used. And I mean, that's why they make fuses too, so that would probably pop the fuse, but that to me, I feel a lot better about this connection now. Okay, now this piece, I haven't decided if I want to run the wire underneath or above or on the side. I'm thinking underneath is where I'm going to go with it. Or do I want to run it up above and over? So this is ground here. I need to go to the positive here, which is on the bottom on the other side. Yeah, I think I'm going to go under it. We're going to have some slack here. I did that intentionally. I'll figure out what I'm going to do with that in a second. It's important before I solder this. Stay on the outside of the strap, go inside the strap. We could do that. So that'll kind of hold it. It's really not that important, to be honest with you. Just leaving it the way it is, because I plugged that in and having a hard time getting it disconnected. Okay, there's the other side. And again, this is going negative of this battery to positive of this battery. Okay? Again, just kind of laying a puddle helps transfer the heat real quick, which is what we want. That's good. And I forgot to put heat shrink on this side. I wanted another piece. That sucks. See what happens when you're in a hurry? All right, well, you guys are going to see how you get one of these disconnected now. So that's going to make it harder to do, but I was having a problem unplugging that in the first place. There you go. Not so bad. I wanted to heat shrink this. Put the heat shrink down on the wire first. Now we got to go back together on this. Now that there's solder on this terminal, I kind of have to do this together. I don't think that's going to plug in. And it's hot, so I don't want to touch it. Can't really get that plugged in all the way because of the solder on there, so we got to heat it. There we go. Plugged back in. Let's get a little bit more solder on that terminal. Too much on there, I think. Ah, that's good. A little shaking, it was just knocking off the extra solder. Let's get this heat shrink on there. Again, some of you might think this is a little bit of overkill here. I'm a car guy. A lot of you guys that are watching this would know what I do, but maybe some of you don't know what I do for a living. I specialize in car electronics. So I am doing automobile wiring, repairs. That's what this channel is all about, actually. And I know enough about shorts and opens and resistance to, guide me real well into what I'm doing here. So that to me is more secure, safer than not having that wire insulated in that location. Just wondering if that's going to interfere with my box at all. That might, putting the side box on this one terminal. I don't know, we'll see. And we'll have a little bit of extra here. What I'll probably end up doing is zip tying this wire up in this area here when I'm done. We'll kind of make everything look pretty when we're done. Let's finish soldering. So now I need to go negative to from here to positive to here, and that's going to be this piece. And again, I'm going to heat shrink this so I don't screw up this time. I'm going to put both pieces on the wire before I begin. This is the right way to do it. Both pieces of heat shrink are on the wire. Okay. Plug in up here. A piece of solder on that. So negative to positive down here. My heat shrink is there. We will start on the bottom because this heat shrink wants to come down that way. So I'll kind of bend the wire, holding the heat shrink up here. I'm going to solder this one now. Real nice and easy. drop this piece of heat shrink down. Probably should do them all now at this point. Maybe redo that first one. And the first one over here, I could pull the terminal out of the fuse and run the heat shrink down over. I may end up doing that. This is where the gun comes in real handy, because I don't have an open flame here. It's just using the kind of heat from the gun for the heat shrink. But these batteries, they're sealed. Open flames next to batteries, guys, is really not a good thing. I had one car battery blow up on me once, and it was just an accident. I was doing a compression test on an engine, and I left a plug wire lay on top of the battery, not paying attention to where I had left it. When I was cranking the engine over, I had forgotten about that plug wire, forgotten to ground it out or disable the ignition, and I cranked it and the battery blew up, and it was pretty scary. So safety glasses is probably a good idea when you're doing this, believe it or not. I have mine on right now. You see? Can I get my head in there? See? All right, positive, negative, positive of this one, negative of this one, coming down to the positive. So negative to positive, negative to positive is next. Got this little jumper wire for the middle. And this one I am not going to use heat shrink on because I don't have room to. So I'm just going to plug this one in. And this one definitely isn't going anywhere anyway. This is the original solid mount of the original battery location, unmodified, 2 new batteries. Again, I got these batteries online for about, I don't know if I told you guys this or not. I got the batteries. They are, what are they called? Mighty something. I don't know, I was looking for cost really. $120 I paid for all 4 batteries. I got them from, did I get them from Amazon? I don't remember. Mighty Max batteries are the ones I'm using. And the reason I replaced the batteries is the other ones were wearing out pretty quick. They were a year old, had a lot of use on them. And I really wanted to get a good gauge of how this thing runs. Unfortunately, I don't have before video of how this ran with new batteries, so I'm really comparing now. Well, I have good comparison. I have the trial runs we did with the old batteries, and this is with the new batteries. So yeah, we still have a decent before and after. Darn it. Okay. And then one last one is my negative over here. And I think what I'll do is I'll take my fuse out for right now on my inline fuse holder. This is 48 volts, you know. You study electricity, anything more than 40 volts is dangerous for the human body. We're warned of that all the time. 40 volts is kind of our number that we worry about. We deal with 12 volt systems on the car all the time, and there's really no concern on the non-hybrid systems. And you know, I have something more dangerous than a car battery with voltage. I can get electrocuted. 36 volts probably would have been okay. I don't know, just regurgitating information that I've read. Have I ever been shocked by a 48 volt battery? No, I have not. So am I speaking from experience? No, I am not. I forgot my heat shrink on that one, didn't I? That's what I get for talking. You know, in a car, the whole frame would be a ground. And this system, I'm just not so sure that that's how it works. I'm pretty sure the frame is not ground on this. It's really just the controller. But I was going to say if that would touch, you know, part of my concerns, I guess, as I'm doing this in the heat shrink is if one of the positives would touch the frame, that the frame is ground. But there really is no ground cable on this system. It's all self-contained. You know, the motor ground goes to the controller, the battery ground goes to the controller, the battery positive goes to the controller. So I don't think the frame is ground on this system, and my concerns of these touching the frame are unfounded because of that. I'm a car guy, so I don't know, a little extra safety is not a problem though. So let's put the fuse in. I am done with the solder. I'm done with my battery pack. Those of you that don't feel confident in this, they do sell the harnesses as well. The same company I got the motor and the pins and stuff from. This will get plugged into my controller. And what I'd like to do with you guys, at least you guys that are following my channel would definitely want this. Let's get some voltage readings on this. Just using a regular multimeter. I got some fancy test leads, but that's the field I work in, so it comes with the turf. And what I want to see here between these two terminals is I want to see 48 volts. And as you see on my meter, 51.9. No problem. It's a little higher than 48 because each battery is a little bit higher than 12. So 51.9 volts, that's good. And so what we want to do now is we want to plug that into the main controller. And when I did this the first time on our test runs, it scared me a little bit because I had some real big arc when I connected to it. And I got scared for a second, but I guess what that was doing was, you know, charging a capacitor or something inside of the controller. All of this stuff I'll have to re-zip tie. Just want you guys to see the connection here. If I did this correctly, can we see that? Yeah. And if it arcs, I'm not going to be scared. Do you see that arc? That was cool that I caught that. That scared me the first time. That arc, when I first plugged in, definitely scared me. Okay, so that's got power now. The unit has power. It's not going to do anything because I don't have my switch connected right now. All right, I'm on the other side of the bike, and if you guys remember, I told you that I had to make a jumper to make this thing turn on, and that's these two blue wires which are listed as a lock circuit. Remember, the lock circuit needs to be complete, the switch, an on-off switch, for this thing to function. What else? I got my throttle is plugged in, main power, motor's plugged in. I don't have a battery gauge plugged in because I'm not doing that right now. That would be cool to have that. Don't have one. Stoplight, I'm not doing that right now. And then this is my charger. And then this is my switch, my on-off switch. Hopefully this doesn't take off on me. Just putting a jumper in there right now. And then what I'll do is I'll lift the back end of this up, and I'll show you guys as I twist the throttle. Okay, we got power. Sounds great, sounds healthy. If I squeeze the trigger of the brake, let me back up so you see what I'm doing. If I did the brakes properly, whenever I give it throttle with the brake pull, so I'll start with the left side. If I did this properly, when I give that throttle, that tire shouldn't move. I'm gonna take a chance this might take off on me. Cool, there we go. Okay, no control, let go of that one. Same thing if I pull this brake, the one on the right, pull that one and give it a little throttle, good. So if either brake is on and you're giving it gas, this bike isn't going anywhere. Let go of those again, lift up on the back. So here's throttle with brake, throttle, brake. I'm still holding the throttle on. And that is the front brake. That was just the tire hitting this box back here made that sound. So both brakes work great. I am pleased with that. It would be sweet to hook up a brake light for this. Let's get some more voltage readings over here. All right, because I am used to using the frame as a ground, I got to get that out of my head for these voltage measurements I'm going to show you. Let's just make sure that you guys can see the meter. Cool. And I believe what I'm going to do is use my negative lead connected to the main negative of this system, which is this connector, and I'm going to back probe that. Nice that I have this little pointy terminal here. That should be able to use that as my reference for all of these measurements. I should be able to. When we're doing measurements on a car, it is the same thing. We're using battery negative for all of our measurements. And again, I need to be careful because this is a lot higher voltage than I'm used to playing around with. And I don't want to get electrocuted. All right, that's motor wires. I'm not going to bother measuring those. I can't do it here. I need another set of hands. I don't have a jack to lift this up. I could show you that. My main thing was our switch stuff. So we can measure the switch, and with it jumpered, I imagine that, well, it depends on design. You guys that are following me, I'm thinking pull up or pull down. Is this a pull up or pull down switch input? And I'll be able to tell you here in a second. So I'm leaving the switch connected, and I have a reading of, what, an initial reading there, 50, wow, I'm shocked that they're running that kind of voltage to that. 51 volts on that wire. 51 volts on that wire. So we're jumping, unplugged. Let's see what we got. Yeah, 51 volts. Let's get off of this auto range, because that's messing us up here. 51 volts on that terminal, 0 on that terminal. So you guys that are following me, this is the computer signal wire, and I would call this a pull-up design switch input. That is exactly what this is doing. Crazy that they're running that high of voltage. So if that module does not see 50 volts or 40 volts, 48 volts, whatever, this is a 48 volt controller. If it doesn't see that voltage on that terminal, it will not turn anything on. So that's pretty cool. Next one we'll do is our brake light. I am curious. Does that say battery? Okay, that's my battery charger. Let me get a reading on these, just because I want to. Nothing on the black terminal. 51 volts. That makes sense. That's wired in to the main circuit. Which one is this? This is my charger. Wait, I'm sorry. The one I just measured for you guys was the battery gauge. So that is reading system voltage. Basically, it's your voltmeter on the system. We could hook up a voltmeter to that. This one is the charger. I would imagine the same thing. Yes. Can we see that? Yep. 51.6 volts on the charger, on the feed wire, the red wire, nothing on the ground. And then last one would be the brakes. My stop lights. This will actually guide me as to what kind of light I'm going to put in this on what I read here. That's more in the way, isn't it? It's better. So the stoplight circuit on the green wire, I have nothing with the brakes off. Can you see that? Arms are in the way. It's like 0.7. Pull the brake. That dropped to 0. Go on the left brake, the right brake, that dropped to 0. Looks like we're applying a ground maybe there. Yeah, this is a ground side switched brake circuit. Hold on, I'll show you in a second. The red wire, I'm going to back probe this. Red wire, because I don't want to spread the terminals in the front. How many people you see doing that? It's bad. 50 volts on the red wire all the time. Not step on the brake, pull the brake lever. You see it staying at 50 volts. Go to the green wire, and we see a trickle, a small voltage there of 0.7, 0.6. Pull the brakes, you see that drop to 0. Either one. So it's a ground side switched brake circuit, but it's a 50 volt circuit. If I run a regular light to this, it's going to burn it out. I'm going to have to run some kind of resistor or something. I'm sure they make specific lights for this, but I can't use a regular 12 volt car light. It'll burn that right out. So good to know. Pretty basic system for sure. The throttle, I could show you the throttle, I guess, for anyone interested in the throttle controls. I think we should show the throttle. Let me go back to the battery. Negative terminal. And it's a mess. Throttle. Get all three. This is the green wire on the throttle. It's 0.8. Black wire. 0. Red wire. It's 5 volts. That's what I thought. This was a 5 volt circuit. So I'm going to pull the brake lever and open the throttle because I don't want the throttle to I don't want the tire to move, but I'll still be able to show you the signal. So twisting the throttle now on the red wire, stay steady at 5 volts. That is a typical reference voltage we use even on our cars. So that's good. The black wire is the next one, moving down the line in the connector. And probably should change our range for this, but we'll stay where we are. Pulling on the brake, opening the throttle, no change, 0 volts. That's our ground for our throttle, the black wire. The green wire should be my signal, and throttle is off. And as I open the throttle, you can see that my voltage is rising accordingly. So 4.3 volts at wide open throttle and 0.8 at no throttle. And let me range that down for you guys to a little bit more of an accurate number. I'll use that. And the material you read on this calls it a Hall effect type throttle. It's still varying a resistor. I would call this a potentiometer if I didn't know any different. There is a Hall effect inside of here that's doing the job of a regular potentiometer, but you can see it's a pretty standard type of signal. Again, there's wide open of 4.3 and nice and smooth and steady all the way back down. So if any of you guys are ever troubleshooting one of these, I've pretty much given you everything you need to troubleshoot this now too. Again, using the main battery ground as my reference. So right where it's going into the controller is where the negative lead of my voltmeter is going, and all of my checks are done from there using the negative comparison. And the numbers, let's be clear about this too, the numbers that I'm showing you would be unique to the application. You might be working on a different type of razor device and your numbers are a little bit different, but they should follow some kind of standard like that. Low voltage, high voltage as you open and close the throttle. Now there could be some out there that work opposite, that start high voltage and drop down when you open the throttle. I don't know, I haven't worked on enough of these. Do we want to have a motor voltage? Yeah, let's get a motor one too. Okay. So for the motor, I'll just do a drop test on the motor and we'll go terminal to terminal. So I'll go the negative and positive. And am I going to be able to lift this, open the throttle, keep everything steady to get you guys a motor signal? Maybe. Got to change this back to my higher scale. Lift this. That was cool. Got 50 volts on that, so I'm gonna have one happy little kid. Nice and fresh new batteries. Last part, I guess, is going to be to get my switch wired up, and I already have that in my charger, so let me get those covers over here and do that. So this cable, something we got to consider is these cables for our throttle switches. We need to make sure there's enough slack, that these cables have movement. So I think I'm good with this here. That's good. I don't need to do anything there. Maybe this fuse, I'm fine with that too. Other side. So I'm using the existing switch. Feed these wires through. Top wires just there. What am I hitting? My batteries are up just a little bit higher than when I checked this before because of my cushions that I put under the battery, so it raised them up a little bit. It's just a little bit tighter fit than I had originally checked it to be, but we're pretty darn close. Nothing that the battery's like hitting right here. Nothing that I can't really move and stretch a little bit, so we're good there. All right, let's see if this switch works on the other side before we bolt everything up. Okay, so we got our jumper out of there. Let's plug in there's two more we got to plug in. Oh no, here's my jumper. Remove that. 2 blue wires are going to go to my created harness, which is my 2 whites. Again, it's a switch, so it should not matter which one goes where. Okay, and if I did this properly, reach over to this side and turn the switch on, which it is right now. Oh, that's what I'm hitting. I'm actually hitting the switch. That's my fuse. It's hitting the switch off of my fuse. That's better. So the fuse was sticking out. Okay. That is with the switch in the on position. Did I do it right? Lift up the bike. Turn the switch off. Lift up the bike. Throttle. No throttle. Reused the existing on-off switch. Cool. All right. Now I got to plug in my battery charger connection. Stoplight. What's that say? Charger. That's my guy right there. And this is my wiring setup. Get you over here. Yeah, probably not going to be able to get that angle for you guys, but the motor itself, does it come in through the bottom? Yeah, the bottom of this down here is the motor wires, will come up there. So those can, really the rest of this I can pretty much just leave it alone the way it is, because there's plenty of space in here for these wires to sit. They're all insulated. We could run a zip tie there if we wanted to. I really don't think that it's necessary. That's actually pretty good. Just need the other half. I may have screwed up on one thing. Looks like I did, but don't know if it's going to be critical or not. I'll show you. Right where my bracket is, right here on the top. I forgot about that interfering with my covers going back on. It may interfere. Something I didn't consider for sure. I'm going to get these screws put in. That sucks. That's why I'm not a fabricator. I bend this down. Don't need much room. That may have actually given me enough. Can you see what I just did? I just took this and bent that down. That might give me enough to get that cover on now. Something to consider if you guys are going to do what I did. I just think this is the best option for the least amount of modifications to the bike. I might need just a little bit more. This should have drilled that down just a little bit more from where I am, and that would have been good. Just pushing down on this is all I'm trying to do. It's in there pretty good. Stupid that I missed that. The rest of that's lined up. That's so close. I'm rushing now. Oh, I think we can make that work. We can make that work. I can stretch that top one over top. Let me get the other screws in. So one little mishap in my otherwise, I think, awesome modification is this top piece, and I should have just put that bracket down lower. What I'm going to do, I don't think I have enough room to move it any lower, so I'm just going to cut the corner of this out right here. I'm going to leave that, hopefully leave that bolt where I can put that together. I'm hoping I may have to completely get rid of this one top bolt for the cover. I don't really want to, because it's really the only well, there's only two up top. There's only one on this side, so I'm just kind of cutting off this piece of housing here. Just using my soldering gun. Alright, so this last part, I was able to pry down on that, and I melted away a little bit of the plastic right above where this bracket is, and this is going to, looks like this is going to do it. So I'm just threading this last piece in. I think the other thing that's fighting me is the battery's kind of hitting right in this area. So it's just a little bit tight. All right, before I bolt the top cover back on, let's get one last run here and make sure that our switch is still working. Make sure I didn't move anything. Switch is off. Lift the back tire. Nothing. Switch is on. Lift it. Couple final safety checks. My switch is on. Pulling on the right brake, giving it throttle. No throttle. Lift the back. No brake. Got throttle. Same way left side. Taking a chance here. Pulling the brake, hitting the throttle. Okay, so good. We are good. It's ready to go. I'm just missing one nut for the other side of the case, and I was always missing the one bolt in the front. Let me get you a view of this and what I did, and I'll put the top piece back on and take this home, have one happy kid. And what we'll do is I'll get some after shots of him riding on the street again. See, it's all enclosed. The last crappy mods I made there, but it's still good. Gets you a little bit better light. So if you guys are going to do what I did, I suggest trying to get this screw that I used for that top battery bracket as low as possible on this piece here. And, yeah, so we should be good. I'm going to use the regular plug-in charger and using the factory on-off switch. No mods to the motor, direct bolt on. Very pleased with that. I was always missing one screw here. Try to find one for that. We're all bolted up though. And again, there's that modification, slight modification I made with melting the corner inside so that fits. It's good all the way down too. Bolted up solid on the frame on both sides. All right, next up is the after runs with the new batteries.